Okay, this is mechanics 2.1 to 2.4 for the periodic in week 11. Maybe you guys will watch this for the final. Separate video will be coming out for past papers, the 3 past papers, and 2 book exercises that I think may come in the written part. Anyways, just a quick heads up that according to the regional, these past papers will not come copy paste, but he's gonna get questions that look like them, but it's just different numbers. Okay, and I'm gonna show you exact steps to solve, how to solve, so you can get your full mark. Okay, a particle moves from point A to point B in 4 seconds. What is the initial distance from the origin? He started at A, so his initial distance would be the magnitude of A, right? So let's put, what's the magnitude of 2, 3? It's 2 squared, 3 squared, 3.6. The average velocity of the particle. The average velocity, when you're working with vectors, is r divided by t. R is final vector minus initial vector. So it's going to be 4 minus 2 over time I, right? Because there's an x component and a y component. And the j component, the y component, j component, 11 minus 3 over the time j. So you're going to get 0.5 I plus 2.0 j. The average speed of the particle. Speed is always the magnitude of velocity. So you put 0.5 squared plus 2 squared. You get, oh no, sorry, radical. Yeah, radical of that. Radical 0.5 squared plus 2 squared. You get 2.06 to 1 decimal place, 2.1. صح? Question 2. They gave you the displacement r, and they want the displacement of the particle in the first second of motion. First second of motion basically means 0, 1. So between 0 and 1. So basically r1 minus r0. صح? Okay, let's find r1. r1 would be equal to 5 plus 4 times 1. I, right? Because the t is here. Plus minus 2 times, how much is the time? We're saying 1. So the time here is squared. So it's going to be 1 squared j. Okay, so you're going to get 9i minus 4. No, minus 2 times 1. Minus 2, صح? Minus 2 j. So this is r1. We want the first second. So it's 1 minus 0, صح? How much is r0 going to be equal to? 5 plus 4 times 0. I. And then since time here is 0, we don't have a j component. So because it's only time multiplier sign. This here it's 5 plus time. So you always have that 5 even if time was 0. Here you're multiplying, so it's going to be just 0. So you're going to get 5i. We want r1 minus r0, so there's no j component to subtract by, so we're just going to take the j component down. Now let's subtract the I components. 9i minus 5i is going to be 4i. So you're going to get 4i plus minus 2j. The magnitude of the average velocity in the first second. Average velocity, they want the magnitude. So basically they want us to find the vector of the velocity and then find its magnitude. This is the displacement, and they want the first second. So obviously in the velocity in the first second would be the displacement in the first second divided by the time, صح? Okay, we found the displacement. We found r01. How much is the time? It's first second, so it's only 1 second. So if you just divide this by 1, you're going to get that the velocity is actually what? 4i minus 2j. And they want the magnitude. Please don't, guys, if you have it in your written, please make sure you put the symbols, vector symbols. So if you find the magnitude of this, it would be radical 4 squared plus 2 squared. Okay, let's see this for radical. Radical 4 squared plus 2 squared. You get 4.5 to 1 decimal place. How do the magnitude of the average velocity v and the average speed s in the first second of motion compare? Here, without even calculating, velocity is delta r over t, right? Realize here how we subtracted, we subtracted 9i by 5i. So the delta r, we had to subtract. You know that speed is just L over t. L is the total path, so L is actually you're adding. Delta r, it's r final minus r initial. So which one do you think is going to be higher? When you subtract or when you add your path? Obviously speed. Okay, so the speed is larger. And what's the best explanation? The trajectory is curved. If it was just a straight line, guys, you know that velocity and speed is the same thing. They're both equal if they're on a straight line, because you're moving in one direction. There's nothing to subtract by. It's the same path. But if it's curved, you guys, like, let's say مثلا A here, B here, and you go like this. You know that the speed here would be the length of this whole path, L divided by T. But the velocity would be the displacement, so it would be the displacement from A to B. So it would be the length of this line. So delta R over T. So which one do you think is going to be larger? Obviously L, because it's curved, so the path is longer than just the straight line. Question 2, as a 3. The position is this. At t equals 1 second, what is the distance from the origin? So let's just find t of 1. So 10 plus 2 times 1 squared, because it's t squared, I. And then plus minus 1 and minus 6 times 1, because t is here. J. What are we going to get? 10 plus 2 times 1 squared is 12i. Plus minus 1 minus 6 is minus 7j. This is the position vector. Do they want the position or do they want the distance? The distance. Distance is always the magnitude of the position. Okay, similarly to how speed is the magnitude of the velocity, because position is a vector, and the distance is a scalar. If you want to convert from a vector to scalar, you have to do magnitude. Okay, so radical 12 squared plus 7 squared, you get 13.9. The magnitude of the instantaneous velocity. Okay, the instantaneous velocity at t equals 1 second. When you want instantaneous velocity, let me try and make this a bit easy for you. Remember when we'd have x of t, you derive to get v of t, and again you derive to get a of t, right? You're gonna need this for b and c as well. Now here we have the displacement, even though it's an r. In vectors, they call it position, they call it r. So we have x of t. They want instantaneous velocity. Remember, instantaneous velocity is velocity at a certain instant, so velocity at a certain time. So I need vt. How do I find vt? It's the derivative. It's equal to dr, derivative of r with respect to time. So what's it going to be? 10 derived, you get 0. 2t squared, derived, what do you get? 4t. So your I is 4t. We're done here. Minus 1 derived, get 0. Minus 6t derived, what do you get? Minus 6. So minus 6j. So this is your vt. They want the magnitude of it. So how do you find it? It's radical 4 squared plus 6 squared plus 6 squared. You get 7.2. Then the magnitude of the instantaneous acceleration. Now they want acceleration. Instantaneous acceleration. So the acceleration at a certain instant. So at a certain time. How do we find it? You derive at is equal to dv, derivative of velocity with respect to time. So what's it going to be? 4t you derive, you get 4i. Minus 6 you derive, you get 0. So you just get 4i. So what's the magnitude of 4? Obviously just 4, because radical 4 squared is obviously just 4. So you're going to get 4 is your instantaneous acceleration. Question 4. We got velocity over here. I and j pointing towards the east and north. Select the diagram that represents the direction of the initial velocity of the particle. طيب, initial velocity is when time equals to 0. صح? طب let's see. If time equals 0, how much is my velocity going to be? Obviously, minus 5 times 0. There's going to be 0i. How about the j component? We have 1 plus, right? So 1 plus. Minus 10 times 0 is 0. 2 times 0 squared is also 0. So you're just going to get 1 plus 0j. So we have no I component. So are we moving to the right at all? No. So the vector is just 1j. You know, 1j means you're going up. So we're going to be this one. The expression for the acceleration is given by what? So basically, they gave you v. They want you to find the expression for the acceleration. How would you find it? Acceleration is the derivative of velocity divided with respect to time. So let's derive this. Minus 5t becomes minus 5. So minus 5i plus 1 doesn't get derived. Minus 10t becomes minus 10. 2t squared becomes 4t. J. Right? It's going to be like this. The magnitude of the average acceleration of the particle in the first second of motion is what? In the first second of motion, so it's A, 0, 1. Did they say instantaneous? They said average acceleration. This is where many students mix up. They're going to go here and they're going to substitute 0 and 1. That's not what you do. Average acceleration. What's the formula for average acceleration? It's V final minus V initial divided by time. Always, if you see average, you never use the expression for that thing. Let's say I want average velocity. I will never use V. I will have to use X, because if average velocity is X final minus X initial divided by time. Okay? So, average acceleration is V final minus V initial divided by time. They said first second, so between 0 and 1. Okay, if they said second, it would be between second would be between 1 and 2. Third second would be between 2 and 3. Fourth second between 3 and 4. Okay, always take what's behind. Okay. طيب. V final is in the first second, so at t equals 1. How do I find it? I'll go back up to here. Let's find it. So it's going to be t equals 1, so it's going to be minus 5 times 1 I, right? Plus, let me erase this a bit. 1 minus 10 times 1. 2 plus 2 times 1 squared plus 2 times 1 squared j. Let's fix this. So it's going to be minus 5i plus 1 minus 10 plus 2. You're going to get minus 9 plus 2. It should be minus 7 j. So this is velocity final. This is VF, right? Type. Velocity initial is at what time? 0 seconds. And we found in part A that it's actually just 1j. We found in part A, remember? Because at 0 seconds, there's not going to be any I. This is going to cancel because times 0. This is going to cancel because it's times 0 squared. You just left with 1j. Okay, so remember let me just put a box around this. So you want V final minus V initial over time. So it's going to be minus 5i minus 7j. That's final. Minus initial, so minus 1j. Divided by the time, how much is it first second? 1 second. 0 and 1 is 1 second. So, minus 5i, there's no other I to subtract it with. Minus 7 minus 1 is minus 8j. Please remember, put vector symbols, over 1. So you're going to get minus 5i minus 8j. What are they asking for? The magnitude. So how do we find it? Take your calculator. 5 squared plus 8 squared. You get 9.4. Question 5. Is this the long quiz? Oh, no, it's not. Okay, 22. The other one I think is 28. The position of a particle moving in a plane is given by the following equation. Okay, whatever. The magnitude of displacement in the first 10 seconds of motion. So, they want the displacement in the first 10 seconds. So, between 0 and 10. Right? First 10 seconds. Now, some people here would confuse and they would say first 10 seconds, oh, they just want R of 10. Okay, now here, for this question only, you'd get the same answer because, صادفت. In Arabic, it's a coincidence. The numbers are very similar. Okay, but in the exam, this won't work. If they said the displacement at 10 seconds, then okay, you just find R10, right? But they said first 10 seconds. So the first 10 seconds, they didn't say 10th. Okay, be careful. Some people would think that it's between 9 and 10. This is only if you say 10th. First 10 seconds, between the first second, 0, until the 10th second, 10. طيب. Now let's solve. R10 تاخد minus 10 times the time 10 plus 2 times 10 squared I, and then plus 1 minus 6 times 10 j. طيب. Minus 10 times 10 is minus 100. Minus 100, 2 times 10 squared is 200. Minus 100 plus 200 is 100i. Plus 1 minus 60 is minus 59 j. This is R10. R0, you're gonna get 0, 0, 0. So all you're left with is 1j. We're doing, obviously, R10 minus R0. R10, 100 minus 0i is going to be 100i. Minus 59 minus 1 is going to be minus 60j. So what's going to be like? You want the magnitude, right? So we're going to put radical 100 squared plus 60 squared. You're going to get 116.6. If you round it, 117. Let me show you that if you didn't put this R0, and it would be 59, right? If you didn't, which would be wrong, it would be 59. You'd also get the same answer, but you get 116.1. When rounded to the nearest integer, it's not 117, but subhanAllah, for this question, they put another possible answer, 116. Yani, okay, if you're lucky, you'll get it. But who's saying that in the exam it's going to come like this, same answers? So please follow what I did, okay? Just to show you, because some people would have probably solved the quiz and say, oh shit, I got 116, it's correct in the answer. No, don't solve like this, okay? One is the velocity of the particle strictly vertical. Strictly vertical معناتها what? That the j there's no I component, right? أكيد نحن we need to find أول شيء what is the velocity for me to see if it has an I component or a j component. Let me erase this. This is my position, right? How do I find the velocity? R, or like it's called x, goes to v, goes to a. So the velocity would be the derivative of r with respect to time. So what's it going to be? Minus 10t becomes minus 10. 2t squared becomes 4t. This is your I component. Plus 1 doesn't get derived. Minus 60 becomes minus 6j. طيب. We now want to see when is it strictly vertical. If something's vertical, it means it's not moving left or right. That means there's no I component. So this I component, minus 10 plus 4t, how much is it supposed to be equal to? 0. How solve this equation, you're going to get 10 divided by 4, 2.5, which is the answer. Okay? How about when is the particle considered strictly horizontal? Let's see. Strictly horizontal, that means no Y component, or let's call it J component. Why? When something is strictly horizontal, that means it's going left and right, not up and down. If it's not going up and down, then there's no Y component, no J component. Let's go to my J component. It's minus 6, equated to 0. You're going to get this. Why is this false? Can minus 6 be equal to 0? Is minus 6 equal to 0? No. So, never. Select the diagram. Sorry. Select the diagram that correctly represents the initial acceleration of the particle. Initial acceleration. So, they're talking about acceleration at a certain time. Time equals 0. Let me see. Do I have acceleration for me to see what the acceleration is? No. I need to find acceleration. So I'm going to do dv over dt. Derive velocity with respect to time. Derive this. Minus 10 doesn't get derived. 4 gets derived to get I. Minus 6 doesn't get derived, so it's going to be 0j. So your acceleration is 4i. 4i. Even if time is 0, time is 15, time is infinity, your acceleration will still be 4i because there's no time variable for me to multiply by, right? So that means my acceleration is going forward to the right. Question 6. I'm going to try and finish this before 12. Acceleration is this. Initially, the particle is at rest at the origin. The values of the horizontal and vertical components of the velocity at the particle at t equals 2 seconds to the nearest integer are what? Do you have to use integration? Yeah, you have to use integration. Now see, and I'm gonna do this is the first time we ever do this in mechanics, but I guess now they could bring it because we did take integration in math. Okay? They want the velocity, but now we have acceleration. How do you find velocity if you have acceleration? Velocity is equal to the integral of acceleration with respect to time, right? dt means with respect to time. Type integrate this to integral of 2 dt. What is it? Remember, you take it down, and if there's no x or variable beside it, you just add a variable. So 2t, so it becomes 2ti. Velocity is equal to 2ti. How about the j component? The j component will be integral minus 6t, right? Minus 6t with respect to time. How do you solve this? Remember, if you always have a number, just take it down. T, take it down. Increase the coefficient, add 1 to coefficient, to the power, not coefficient. Add 1 to the power. It was 1, but it's here 2, right? And divide by the new power. So your expression for the velocity is equal to 2ti minus 3t squared j. They're saying what is the value at t equals 2 seconds? So substitute t, 2 times 2i minus 3 times 2 squared j. So you're going to get 4i minus 12j. Vector symbols always, huh? So 4 and minus 12. The distance of the particle from the origin at t equals 2 seconds is how much? Distance. So they want now distance. They want r or x or whatever. Can I find x if I have velocity? Yes, I can. So my velocity is this. I know that. Let's call it r instead of x because I'm working with vectors. I don't like to call distance as x or displacement. I'd like to call it r. R is equal to the integral of v with respect to time, right? Remember, it goes from r or x, whatever you want to call it, to v to a, right? To a. So and I'm going back, so I have to integrate, right? So r is equal to integral v dt. So it's gonna be integral 2t dt I, right? Plus, what's the j component? Integral minus 3t squared with respect to time, j. Let me put this in brackets. Type, so it's going to be r is equal to integral of 2t, take 2 down, increase the power by 1 squared, and divide by your new power, plus integral, take minus 3 out, t out, t out, sorry, increase the power by 1 and divide by the new power, j. What is it going to be equal to? 2 over 2 gets cancelled, so it's going to be t squared I. Minus 3 over 3 is minus 1, so minus t cubed j. At t equals 2 seconds, how much is it? It's going to be 2 squared minus, I think I did something wrong, but let me continue. 2 cubed, yeah. Wait, no, what am I doing? Sorry. At t equals 2 seconds, it's going to be 2 squared I, right? Minus 2 cubed j. So it's going to be 4i minus 8j. And they want the distance, so you should always know distance is the magnitude of the position. So what are we going to do? Radical 4 squared plus 8 squared. You get 8.9 to the nearest integer is 9. I don't know why I got a bit confused at the end. Just normal integrate. You get t squared I minus t cubed I. And then substitute, you get 2 squared minus 2 cubed ij. You get 4i minus 8j. But they want the distance. Always know the distance. They're basically asking for position, but find its magnitude. Okay? Always. Hatta if the vector is given distance, you just always remember we said it's just a magnitude. Why I got a bit confused. When you integrate, I was supposed to write for you plus c. But since they're saying initially the particle is at rest at the origin, that means at time equals 0, v equals 0, x equals 0. Whenever you have 0, 0, you don't need to write plus c. But I didn't mention that, so some people will get confused. I doubt integration will come, but yeah, in case, guys, this is how to integrate. We did it in math as well. Question 7. A particle is moving, okay, we did this in our AMS before, along a curved trajectory shown below as a dashed line. It moves from A to B in 4 seconds. The velocity vectors of the particle A and B are shown in the diagram. Below, the length of one square is 1 meter per second. So they gave us the vector. So velocity of A, let's see how much is it. It's 1 to the right, so 1i. And 1, 2, 3, j. How about B? 1, 2, 3, 4, I. Goes up by 1, so 1j. Okay, you're going to need these for later. Select the diagram that represents the direction of the average acceleration of the particle as it moves from A to B. Average acceleration is equal to velocity final minus velocity initial divided by the time. So I think you just do 4 minus 1. Yeah. So you're going to do 4 minus 1, B. Our final one is B, so because we went from A to B. So our final, so VB, let me write this, VB minus VA over T. Velocity of B, we're going to subtract I components and J components separately. 4 minus 1, 3I. 1 minus 3 minus 2J. Over the time is going to be 4. So, you can find this out. It's going to be 3 over 4 I minus 2 over 4 J. If you want to make this in decimals, 0.5i minus 0.5j. These steps were not necessary. You can just see directly from here. If it's positive, it's going to the right, right? If it's negative for j, that means it's going down. So if it's going right and down, so how much is it going to look? It's going to look like this. So you choose this one, okay? But you're going to need the step for this one here, because they're going to tell you now, find the magnitude. What is the magnitude? They said 4 seconds, that's why I divide by 4, huh? How do you find the magnitude? Radical 0.5 squared plus 0.5, radical 0.75 squared plus 0.5 squared. Okay, you're gonna get 0.9 to 1 dp. Question 8. The expression for the velocity moving along the circle of radius 25 is given by v is equal to 3 sine 2 rad t plus 3 cosine 2 rad t. The normal component of the acceleration and the tangential component. Without doing part A, if it's moving along a circle, that means A tangential is always equal to 0. صح. Okay. The normal component of the acceleration. Yeah. So I forgot the formula صراحة. But these are all the UCM formulas over here. Normal acceleration is equal to v squared over r, which is equal to 4 pi squared r over whatever. Don't use this formula. It's better to use 4 pi squared r f squared. Okay, this is better for a normal. You're gonna get this. You might use this later. Just putting it out there from now. I don't know if you can use it in this quiz, but I saw a question. It was in chapter 3 about it. So just like heads up. So a normal for this one here, since we have the velocity and we have the radius, we're obviously gonna use a. Let me erase this. We're gonna use a normal is equal to v squared divided by r. Okay. What is the velocity? 3 sine 2 rad t. Okay. Okay, I don't know where I stopped, but I had to go get something. But yeah, I think I was saying normal acceleration is v squared over r. The velocity is 3 sine 2 rad and 3 cosine 2 rad. Okay, so I think the seconds cancels with the time. That's why you don't multiply. But you're gonna get 3 sine 2 rad. 3 sine 2 rad. Hold up. How do you do it on the calculator? Was yeah. 3 sine 2 rad I. Yeah, that's my I component. And the J component is gonna be 3 cosine 2 rad. J. We want to find the velocity, right? V squared over R. This is V. طب I want velocity. So I need to find the magnitude of this. Right? So how am I gonna do it? Put it under a radical. Squared. Squared. How do I find wait, let me Ya Allah. I hate it when I explain like this, man. This is the velocity. I want v squared over r. So I need the magnitude of the velocity for me to solve. I can't just find I component, j component. I want a final answer, right? So let me find the magnitude of the velocity. It's going to be the I component, 3 sine 2 rad squared, 3 sine 2 rad squared, plus 3 cosine 2 rad squared. You're going to get 3 when you do this. But please pay attention. If you do it in degrees, like look, most of you are going to get this. You're going to be like, oh shit, what are you doing? 3 sine 2 plus 3 cosine 2 squared أكيد يعني. You're gonna get أصلا it won't give you an answer. Oh no, it would. Degrees? I think you get the wrong answer. Wait. Oh, you'd get the same answer? Then square divided by 0.25. Huh. Okay, you get the same answer. But see, you're not supposed to do it like this. I'm 100% sure you're not supposed to do it like this. You're supposed to shift your calculator to radians whenever you see rad. Okay, maybe صادفت it might work for this one. But you're supposed to solve with rad. Okay, so again, let's put this in our calculator. This rad basically means switch your calculator to R. Okay, and then don't mistake it and like later. Listen, if you ever don't know, check the top of your calculator. If it says R, yani it's radians, and then if it's in degrees, please make sure. It would be يعني haram if you get mistakes because your calculator was on radians. Here's degrees. Okay, so change it to radians. you're gonna get radical 3 sine 2 squared. I was supposed to put a bracket here. And then plus 3 cosine 2 squared. You're gonna get 3. So this is my v. So v equals 3. Okay. So now v squared over r, so it's gonna be 3 squared divided by the radius. The radius is 25 centimeters. Make it meters, 0.25. You're not allowed ever in physics to use centimeters. So over 0.25, and you're gonna get squared divided by 0.25, 36. And like we said, tangential component of the acceleration is always 0. Question 9. The magnitude of the speed of a particle moving in a plane given by v is 2 meters per second plus 3t. So 2 plus 3t. So v is equal 2 plus 3t. At t equals 2, the particle is moving along a curve of radius 5. The normal component, the tangential component, and the acceleration. Very, very, very important that here don't put tangential at 0. Why? Because it's not UCM. It's only 0. It's only 0 in UCM. Okay? Here, even though they said radius 5, that doesn't mean it's UCM. They said it's a curve. So you're going like this. Okay? طيب. The normal component, the tangential component. Again, you're going to do v squared over r for the normal component. V is 2 plus 3t. They're saying at 2 seconds, right? So, how do you find the velocity at 2 seconds? 2 plus 3 times 2. You're going to get 2 plus 6, 8. So 8. So 8 squared divided by 5. You should get 12.8 if I'm not wrong. 64 divided by 5. 12.8. Because 8 squared is 64, huh? The tangential component. The tangential component, if you don't have it, I think you're supposed to derive. So I need to make sure. Yeah, you derive. Yeah. So tangential component is always the derivative of velocity. كأنك you're finding the normal acceleration. You just derive velocity. Because if you have a circle, I'll explain this. You know, I think I drew it in my book. Over here. Yeah. So the tangential is this one. It's the tangent. This is also the tangent. This is also the tangent. It's the same as just the velocity's direction. Okay? But the normal component is actually this one. Actually, I drew it. I drew it somewhere, no? Yeah, here. It's this one here. It's the one going down. So if I were to draw here on my big circle, the normal component would be going like this. It's always changing direction. Because the tangential one, it's the same thing, yani, over and over again. That's why the normal acceleration changes, but the tangential always stays constant in UCM 0. But anyway, tangential component, you just derive velocity. So AT is equal to the derivative of velocity with respect to time. So you're going to get derive 2. You get, oh shit, 750. Derive 2, you get 0. 3t, you get 3. So that means A tangential is 3. And now you have tangential and normal. How do you find the total acceleration? It's equal to A tangential squared plus A normal squared. So it's going to be 12.8 squared plus 3 squared. So you're going to get, should be 13. Let me see. Radical 12.8 squared plus 3 squared. You get 13.1. Solve one more question. And you're not going to see it, but I'm going to go and get something. Go pray. Oh, okay. R1 is this. R2 is this. So this is velocity of both 2 relative to both 1. Okay, yeah, this is easy. What is this? Okay, this is easy. Okay, velocity of both 2 relative to both 1. Remember, this is, I think, the closest approach. When you have two vectors, actually you need to find their velocities with respect to each other. Okay, this is the position. Let's actually find the velocity. So you derive. So v1 is going to be 8t. Derived is going to be 8. And 9,000, we don't take it. It doesn't get derived. And then 2t becomes 2j. 1,000 doesn't get derived. V2 is going to be minus 10t is minus 10. 10t is just 10. Sorry, 10. ليه حطيت t and j. So the 2,000 doesn't get derived. Right? You guys know how to derive. I'm not going to explain how to derive. So this is V1, V2. طيب. Velocity of both 2 relative to both 1. Remember, you'd have to multiply the velocity. You'd find the time. like, where was my closest approach? كتبت شي مكان. It was 2.4. Yeah. You'd use this one formula. And yeah, here. It's the final position is equal to the velocity times the time plus the initial position. Okay. Go back here. I don't think you need it. You can just follow the steps of the question. Both 2 relative to both 1. You just do minus 10 minus 8. So it's minus 18. And then 10 minus 2. It's 8 plus 8. I think you have to say plus. I don't know why. That's stupid. Okay. The boats meet after 500 seconds of motion. Basically, when they meet, R1 is equal to R2. I think. Let me just solve this because I'm a bit sketched out about this. R1 equal to R2, you're going to get 8t minus 9000 is equal to minus 10t. You should get 9,000. You get 4,500, no? Well, 9,000 divided by 18. Yeah, you get 500. You get time is equal to 500. Because R1 equals R2. So you can either equate the I components or you can equate the J components. It was easier for me to equate the I components. So T equals 500 and you can equate the J and you'll get T equals 500. The coordinates of the meeting point are X equals what and Y equals what. Akid, just substitute now 500 and see what you get. 8 times 500 minus 9,000. I'll substitute into the first vector, okay? You're going to get 4,000 minus 9,000 minus 5,000. And your J component, substitute 500. 2 times 500 plus 2,000. You're going to get plus 3,000 J. So minus 5,000 plus 3,000 J. So minus 5,000 is the X, 3,000 is the Y. Okay. I think I'm back now. We finished 10. 11. This is closest approach. How do you know you're working with the closest approach? When they say the smallest distance, that means you're using closest approach. Closest approach has a few steps. It basically, when you memorize this formula, RAB equals R capital AB plus VAB T. This formula is the first step. Then the second step, after you find out what RAB is, you're basically going to say RAB is perpendicular to VAB. Basically saying RAB times VAB is equal to 0 and you solve. You're going to get something. So knowing these two steps, I'm going to solve this for you now. Some people still get a bit confused what I mean by small and big. Big is always your initial position. So like robot 1 is initially at the origin. So its initial position is 0, I, 0, J. And then robot 2 is initially at 0, 5. So 0, I, 5, J. So this is RA capital and this is RB capital. Let's call this robot 1A, call robot 2B. Okay? Okay. So I don't know where I stopped. I had to go, come on. But I think I stopped here where I wrote down the steps for you. And I told you that we're going to call robot 1 as A and robot 2 as B. And this is its initial position. The small one always means final. Yeah, so I keep repeating myself. The capital letter means initial position. The small letter means final position. If you want to write the formula in a different way, maybe you could memorize it in an easier way. I don't mind. This is what I'm going to do, okay? When I say AB, it basically means B minus A, okay? Or, in other words, what did they say? Position of robot 2 relative to robot 1. So actually, you know what? We're going to call, say the other way around, robot 1 as B, robot 2 as A. Because they said R2, 1, so 2 is A, 1 is B. Just so we can memorize it a bit easier. Just so we can solve easier. Okay, so when I say R21, it basically means R1 minus R2. صح? 1 R1 minus R2 final minus initial. So in this case, we're going to be doing R21 would be RAB, which is RB minus RA. Okay, that's a lot of yap. Let me actually start solving. Anytime you see smallest distance, you write down your formula. R small AB equals R big AB plus VABT. Okay? After that, you're going to solve for RAB. Let's see. RAB, this is what they're asking. They want R21, RAB. That's what they want. They want the final position. What's it equal to? RAB, capital AB. It means the initial positions. These are the initial positions. The initial position of A. What's A? It's 0.05. What's B? It's 0, 0. So it's B minus A. Shit. It's the A minus B. It's RA minus B. When you say RAB, means RA minus RB. Because like here, R21 is R2 minus R1. Yahi, whatever. So here, RAB is equal to RA minus RB, right? Plus VABT. VAB times the T. What's the initial position of A? It's 0, 5. So 0I plus 5J minus RB, the initial position of B, 0, 0. So minus 0 minus 0. So what are you going to get? You're just going to get 5J, right? Plus VABT. What's VAB? VAB is equal to VA minus VB. What's VB? We said robot 2 is, which one's A? We said robot 2 is A. So what's the velocity of A? 1I minus 0.2J. So it's going to be 1I minus 0.2J minus VB. What's VB? We said robot 1 is B. So 0.4I plus 0.3J. 0.4I plus 0.3J. Vector symbols, huh? Times T. We have C times T. So you're going to get 5J plus 1I minus 0.4I is 0.6I. Minus 0.2 minus 0.3 minus 0.5 times T. So you're going to get 5J plus 0.6I. Or no, I have to put the I first. You're going to get 0.6IT. Or no, 0.6TI. You say the T then I. Because we're multiplying by T, right? I. Now, plus 5 minus 0.5T J. What did you just do? Look, this is J, this is J, so I put the J on the side. I subtracted them. What is this? 5 minus 0.5T. Because this is 0.5T, I have to subtract them, right? So we're going to put 5 minus 0.5T J. Anytime you have T outside, you can just take the J's together and then put the T outside. Put the T with the thing you want. Okay? You can just put the numbers together and then put the T with the number that's being multiplied by T and then take the J outside. Okay? If you want me to simplify what I just did, I'll do this an extra step just so you can see. 5J minus 0.5T J. صح? In math, can't we factor stuff out? If you factor out J, it's going to be like this. 5 minus 0.5 T and take J outside. That's basically what I just did. You can do the extra step. So this is now RAB. Okay? 0.6 T plus, they swapped it around. I put 5 minus, they put the T first. So be careful in the exam, huh? Since the T is first, you put minus 0.5 first plus 5J. The smallest distance between the robots. Now you do that they're perpendicular. We finished the first step, we found RAB. Then you do the second step, RAB is perpendicular to VAB. What does this mean? That means RAB times VAB equals 0. So 0.6T I plus 5 minus 0.5T J times VAB. What is VAB? VAB, we found it's over here, 0.6I minus 0.5J. In other words, VAB is VA minus VB. So this one minus this, because you said this one's A, this one's B, huh? Because 2, 1 means, remember, we're always saying AB. That means 1 is B, 2 is A. That's why I did this way. Okay? Times VAB, which we said is 0.6I minus 0.5J. 0.6I minus 0.5 j equals what? 0. When you're multiplying vectors, what do? It's 0.6. You multiply the x components plus plus multiplying the y components. So multiply the x components, 0.60 times 0.6. That's x components plus the product of the y components minus 0.5 times 5 minus 0.5 t. صح? What's this going to be equal to? 0. Now you solve this like it's math. 0.6 times 0.6. Take your calculator. Also, you can just put this in a calculator. Let's say, look, 0.6 times 0.6. You should get 0.36 plus minus 0.5 times 5 will be what? 2.5. So minus 2.5. Minus 0.5 times minus 0.5 is 0.25. So it's going to be plus 0.25. T is equal to 0. So you can get 0.36 plus 0.25 is 0.61. I should put T here. T 0.61 T minus 2.5 is equal to 0. So you're going to get 0.61 T is equal to 2.5. Divide by 2.5 by 0.61. Should get 4.21 decimal place 4.1. So T is equal to 4.1. That's the time. We found the time. They want the smallest distance. How do you find the smallest distance? Just take any of the distance vectors. Like, نحن we found RAB to be, yeah, نحن we got the position is this. So now that you have the time, you can just substitute the time, get the vector, and like we said, the distance is always just the magnitude of the position. So we're going to go back here and substitute 4.1. So 0.6 times 4.1 I plus minus 0. Oh, I'm going to continue down here. Minus 0.5 times 4.1 plus 5 j. Let's do it. 0.6 times 4.1. It's 2.46. So you get 2.46 I. And then the j will be minus 0.5 times 4.1 plus 5. 2.95 j. Find the magnitude of this. You're going to get this squared plus 2.46. Oh shit. Radical answer squared plus 2.46 squared. You get 3.8 to 1 decimal place. So, to recap what I did here, it's a bit long, but the first thing, anytime you see closest approach, identify your A, identify your B. So in this case, we said A would be the second one because they said 2, 1. Instead of saying 1, 2, they said 2, 1. So A would be what? It would be 0, 0, the initial position, and B would be 0, 5. Okay, then identify your VA, VB. VA, we said, it's the second one, 1I minus 0.2 j, and the VB was 0.4I plus 0.3 j. Then the rest is just solving. Just solve. Then after you calculate what RAB is, you then say RAB is perpendicular, and then that means the vectors product is equal to 0. And you know when you multiply vectors, you take the I component multiply plus the j component multiply. Okay, and since they're perpendicular, they equal 0. Okay. Question 12. Okay, this one, two cyclists each traveling at 5 meters per second from the same point. The cyclists move along trajectories, the angle between which is 30 degrees. The relative speed is what? Okay, the relative speed of motion. Okay, the relative speed, you do V, I don't know, let's say this is cycle 1 and this is cycle 2. Okay, V cycle, the relative between them is V cycle 1 minus V cycle 2. So, take this to be the x-axis. This will be 15 degrees. This will be also 15 degrees. Resolve cycle 1 into two components. Cycle 1 has an x component. What's it going to be? 5 cosine 15. Cycle 1y is going to be 5 sine 15. To make this easier, because you're gonna need this in chapter 3, it would be easier to draw y-axis هيك حلوة y x هيك. Okay, and then you can draw like this. Like you could say, let's call this cycle 1, cycle 2. You could say this is cycle 1x. This would be, sorry, cycle 1y, because it's going up. And this would be cycle 1x. Command, this would also be cycle 2x, because cycle 2x would be along this trajectory. This would be cycle 2y. Okay. Then cycle 2x. It's still going to the right, so we're going to keep it as positive. And how do you do it? Okay, this one's 15, this one's up is 15. So 5 cosine 15 كمان. Cycle 2y is going to be, now you're going down, so it's going to be negative 5 sine 15. I'm sure you all know that you can resolve y component by multiplying by sine of the angle, and then x component by multiplying by cosine of the angle. Okay, if the angle is with the horizontal, and in this case it is. Okay, so it's going to be v cycle 1 minus v cycle 2. V cycle 1 is 5 cosine 15i. Just so you can help understand. 5 cosine 15i plus 5 cosine, as the 5 sine 15j minus 5 cosine 15i minus 5 sine 15j. I think you guys got what I did here, right? Always when you say relatively, and you subtract them both. 5 cosine 15 minus 5 cosine 15. 5 sine 15 minus 5 sine 15 is 10 sine 15. Why? Because minus becomes plus. 5 plus 5 is 10. So it's going to be 10 sine 15. And you're going to get 6 point. Oh, I think I'm on radians. I'm hoping that's the reason I got it wrong. Because I can't really think of any other. Yeah, 2.6. Okay, I got scared. Well, I'm like, oh, what am I doing wrong? But to one decimal place, it's 2.6, right? طيب. At 10 seconds, the distance between the cyclists is, yeah. At t equals 10 seconds, what is the distance between the cyclists? Obviously, if they're moving along 5 meters per second, it's a constant velocity. So, okay, the distance, you just multiply the velocity by the time. And we said that the velocity is 2.6, so 2.6 times 10 is equal to 26 meters. Okay. Question 13. The diagram below shows the oh, this is easy. Path ABC followed by a girl walking her dog for 0.6 hours. Okay, the average speed of the girl. Okay, this is her trajectory. The average speed, always take the length of the path divided by the time. The length of the path, if she's going from A, B, C, so A plus B. Yeah. It's 6.3 because it's 0.6. Yeah. So A plus, you from A to B to C is 1 plus 2.8, 3.8 kilometers. Divide by the time 0.6 and you should get 6.3. 3.8 divided by 0.6, you should, yeah, that looks like 6.3. 6.3 kilometers. And what is its direction? Obviously no direction, because speed is a scalar quantity that only has a magnitude. The velocity of the girl. The velocity is equal to delta r divided by the t. The delta r is the displacement from A to C, which is 3 kilometers over 3 kilometers. 3 kilometers divided by the time 0.6, you should get 5. Makes sense to get 5. Yes, you'd get 5. And obviously velocity is a vector, so it has a direction, and we're going from A to C, so it's going from south to north, so obviously directed due north. Question 14. A light toy car can move in still air at 0.8 meter per second. A gust of wind begins to flow perpendicular to the direction of the car's motion at 1.2 meter per second. The speed of the toy car relative to the ground. So, the toy car, okay, so we want, when you have relative to this, when you have like 3 objects, 3 relativities, I like to write like this. Toy car, so let's say car relative to ground, is equal to this. 2 velocities. First one will have C at the start. The second will have G at the end. Because you know, like, VAB is equal to VAC plus VCB. You know, when you add vectors, you only take the first and last. So to resolve this, you take this at the start here and this one at the end here. That's just what I'm trying to tell you. So if VCG will be VC something plus V something G. What are we saying? Let's see here. We're talking about the car and air. So we're going to talk about the air. طيب, let's see. What we have that the car relative to air is 0.8. And we have that, yeah, so this is the car with respect to air, it's 0.8. Then they say that the gust of wind begins to blow perpendicular to the direction of the car at 1.2. So they gave us that the wind or the air is 1.2. But here's the key word, perpendicular, okay? When we say perpendicular, that means you now have two separate directions. Let's say that the car was moving like this. This is, let's say, the I direction. This is the car's motion. The wind blows perpendicular to it, so it blows like this. If it's perpendicular to it, that means if this was going to the I, this is now going to be J. So, in short terms, anytime you see perpendicular and it's a relative motion question, usually, and you read the question, make sure of it. But anytime you see a relative motion question and they say perpendicular or in the opposite direction, no, not in the opposite, or yeah, usually perpendicular or normal to it, then if you want, the easiest way to do it, just say that it's equal to radical 0.8 squared plus 1.2 squared. Let me show you why. Let's say here we're moving in the I direction. Since here it's perpendicular, it's going to be in the J direction. So the car with respect to air would be 0.8 I. With the air with respect to ground is 1.2 J. So you're going to get that VCG is 0.8 I plus 1.2 J. And how do you find the speed? It's just a magnitude. So you take 0.8 squared plus 1.2 squared, or you will get 2. Oh. Yeah, أنا مسطل اليوم. You get 2.08. But I keep on forgetting that it's the magnitude. If I do radical, yeah, so you're supposed to do radical 0.8 squared plus 1.2 squared. I forgot about the radical. So you take this and then you do radical. Your answer, oh wait, 0.8 squared plus 1.2 squared. You get this, then radical of your answer. You get 1.44. Question 15. Finally, some projectile motion questions. Okay, yeah, see the rest, and I like the projectile motion questions because they're chill, yani. Yeah, they're very easy. I like projectile. With like now, after the relative motion, I prefer projectile motion. A stone is thrown from the top of a cliff with a speed of 15 meters per second at an angle of 30. So easy. V naught 15, theta 30 degrees. We're gonna fly through these. The total time of the flight is 5 seconds. I've solved this question on the channel maybe 4 times. UG equals 9.8. What is the initial vertical component? V node y is equal to V node sine theta. So it's gonna be 15 sine 30, which is obviously 7.5. How long does it take the stone to reach point Y? 2 ways to solve this. They said here, they drew a line for you that point Y is at the same Y as the initial point. Okay, so I honestly don't know where I stopped because I want to get something. I think I was doing part B. And how long does it take to reach point Y? There's 2 methods for you to use. You can either use the fact that it ended up at the same Y. So that means the Y, the change in Y is 0. Because you started here and you ended up at the same point. So Y equals 0. You guys know that Y equals minus half GT squared plus P naught sine theta T. So 0 is equal to minus half 9.8 T squared plus V naught sine theta, which we found in part A to be 7.5 T. So minus 4.9 T squared plus 7.5 T is equal to 0. And you should get 1.5 minus 4.9, 7.5, 0. You get 1.5. What is the height of the cliff? The height of the cliff, let's see here. They want this H, so we want this here. We know that the time to reach that is 5. So we can easily plug in Y equals minus half GT squared plus V naught sine theta T and use what time? 5 seconds. So we're going to get Y is equal to minus half. G is 9.8. T is 5 since we're finding the final position. It's the cliff H. y equals minus half gt squared plus v naught sine theta t. So 7.5 times 5. And you should get a negative answer because you're going down. So h should be equal to negative y in this case. So you're gonna get. So basically, what I mean by this is that the height is gonna be the negative of what you get here because you're going down. Okay, so minus half times 9.8 times 5 squared is 25 plus 7.5 times 5. You get minus 85. So h is equal to minus 85, which is equal to 85. You guys know if you get it, just make it positive. Why? What I'm trying to say here is just don't be surprised if you get a negative answer because obviously we're going down, so you're gonna get a negative answer. Question 16. A shell is shot with a muzzle velocity of 120 meters. So this V node is 120 at an angle of 40 degrees. Theta equals 40. G is 10. The time taken for the shell to reach a height that is same as its initial height. Whenever we say same as its initial height, basically we're saying time total. Like let's say مثلا you have your projectile here. You start over here. You go and you finish here. Isn't the height here the same as the initial height? Yes. And isn't that the total time? Yes. So you just use the time total, 2 V node sine theta over G. Okay, 2 V node sine theta over G. So it's going to be 2 times V node sine theta is 120 sine 40 over 10. Let's see. 2 times 120 sine 40 divided by 10. 15 seconds. So question 17. Projectile is launched 30 meters per second, 37 degrees. So V node is 30 meter per second. Theta is equal to 37 degrees. G is equal to 10. The speed of the projectile at the highest point, always at the highest point, V is equal to Vx, which is equal to V naught cosine theta. Always, because at the highest point, when you reach here, what's the speed? This is the projectile. The derivative of it, this is position, right? Y, x. What's the derivative of position velocity? So it would be the tangent. Derivative is always the tangent. The tangent in this case is horizontal at the highest point. That's why the velocity at this case is only, since it's horizontal, it's only x component. But in other places like the tangent here, it would be going a bit to the right and a bit up. Going here, it would be here to be going to the right and down. So what I'm trying to show you is that at the highest point, it's horizontal, it's the tangent. So that means the velocity is only Vx. How do you find Vx? V naught cosine theta. So 30 cosine 37. 30 cosine 37. 23.9. So the nearest integer, it's 24. Okay. The maximum height attained. Maximum height is always V node squared sine squared theta. Sine 2 theta. No, sine squared theta. What was it? Shit, I forgot. What was it? 2.1. Was it sine? I think it was sine 2 theta over G. It doesn't want to load. Yeah, okay. Oh my god. Let me cut. Yeah, height is V node squared sine squared theta over 2G. The range is V node squared sine 2 theta over G. Okay, so this is going to be V node squared, so 30 squared sine squared theta, so sine 37 squared over 2 times 10. Okay, so you're going to get 30 squared at sine 37 squared. Oh, I should close the brackets here. Over 2 times 10. That's not a 9, huh? This is a 10, huh? 10. You get 16. The shape, okay. Listen, I'm telling you what I feel. Listen, this is like any other projectile question. He would not include this part if he's not going to bring it. Because you never ask this. He wouldn't include it. If he wasn't going to bring it, he wouldn't put it. Just know it. The shape of the trajectory is a problem. Even if he doesn't bring it, know it. Because in my opinion, it's kind of sketchy. Nobody asked this question. Parabola. Why is it parabola? Man, look at it. Look. Pew! It looks like a quadratic, yeah? This is what we call a parabola. Okay, parabola. Question 18. يلا 4 questions left. حسيت إنه شوي projectiles they're a bit faster. A 60 kg parachutist jumps out of a plane. Take G equals 10. The initial acceleration of the parachutist to the nearest integer. Okay, honestly, I don't think this is questions included because these quizzes are kind of old. Uh, yeah, I'm not sure because this falls under chapter 1. Because this is from the old book, by the way, huh? But I will solve it anyway. The initial acceleration, obviously, when he jumps, his acceleration is going to be equal to the gravitational acceleration, so it's going to be 10. When the parachutist reaches its terminal velocity, what is his acceleration? You guys, we didn't take this, but terminal velocity, we took it last year. And in case you take terminal velocity is when خلاص the air resistance, the drag force is equal to the force of his weight. So it's now moving at a constant velocity. Obviously, his acceleration is 0. Okay, so this is drag, this is weight. Okay, and obviously the maximum force of drag is equal to the weight. The weight is equal to mg. This is chapter 3, not chapter 2. So you're going to get 60 times 10, which is 600. Okay. This is an easy question. Yeah, I'm not complaining if they bring this. A ball of mass 200 grams is projected from the... This isn't from our chapter. A ball of mass 200 grams is projected from the ground vertically upward with a speed of 15. Okay, so V node is equal to 15. Take G equals 10. What is the weight of the ball? Okay, W is equal to mg. Because you're going to need this for chapter 3. I'm going to explain it. The mass is 0.2 kilograms times G is 10. Okay, the time the ball remains airborne. Okay, that's a good question. Oh, yeah. Since they said from the ground vertically upward, that means theta is equal to 90 degrees. So the time, remember the time, total time is equal to 2 V node sine theta over G. So it should be 2 times 15 divided by 10. And yeah, you get 3 when you do this. The maximum height above the ground, height is equal to V node squared sine squared theta over 2G. So you're going to get 15 squared sine 90 squared over so 20. I just here, and I didn't write sine 90 because, guys, sine 90 is equal to 1, huh? You can do this on your calculator. Plug in 2 times 15 sine 90 over 10. You're going to get the same answer because sine 90 is equal to 1, huh? 15 sine 90 is the same as 15. 15 times 1. Anyway, so here, command sine 90 squared is just 1, so we don't care. 15 squared over 20, you should get, let's see, 15 squared divided by 20. 11.5. The nearest integer is 11. The speed of the ball just before it hits the ground. Just before it hits the ground, we want the velocity. Wait. Okay, yeah. I was overthinking this, but the speed before it hits the ground is always equal to the speed as it's thrown up, okay? Always. V final is equal to V initial for projectile. Okay, so it's going to be 15. The ball is substituted by a rock of mass 400 grams. The rock is projected vertically upward with the same initial speed of 15. Indicate what values will change. Okay. The weight of the body obviously will change if you change the mass. The time airborne, obviously, yeah. Since they said neglect air resistance, you guys know air resistance is more if there's a higher mass, so it's gonna slow it down. But since they said no air resistance, yani they're all gonna fall with the same acceleration, so the time will not change, and so will the maximum height won't change, and the speed won't change. That's because we're neglecting air resistance. Okay. However, air resistance plays a very, very big role. You guys know, yani obviously in real life, you know how we learned that all bodies will fall down at the same speed. That's only if you neglect air resistance. But in real life, if you take a 5 kilogram book and a 500-gram book, you drop them. Obviously, 5 kilogram book will fall faster because of air resistance, as they will fall. Yeah, because of air resistance, will fall faster. But ideally, since we're in the books, we always neglect air resistance. That's why here, since they're saying neglecting air resistance, people say, oh, you increase the mass, يعني بسرعة, it will fall faster, كل شيء. But they're saying neglect air resistance. And they will always tell you to neglect air resistance. Question 20. Oh, shit. A ball of mass 200, نفس السؤال. This 200 is projected horizontally, يعني theta is equal to 0 degrees, from the top of a 20-meter building with a speed of 21 meter per second. Take G equal 10 and neglect air resistance. The time for the ball to reach the ground. Okay. Usually, نحن what do? We do time total is equal to 2 V naught sine theta over g. بس نحن if you do sine 0 هلا شو هيطلع لك 0. So you can't use this equation. So always know that y is equal for whenever you have horizontal and you ask for any time or height or anything, you can only use this equation. Okay, v naught sine theta t. But this is gonna cancel because sine 0. So we're gonna get y is equal to minus half gt squared. Okay, y is how much? It's a 20-meter building. You start here. You finish 20 meters below, right? So what's the y gonna be equal to? Negative 20. Please don't put positive, huh? Think about it. Equals, always y is your final position. Minus half times 10 times t squared. And I'm gonna make my life easier. I wanna cancel these. Okay, so I'm gonna get 20 is equal to 5t squared. Divide by 5, you're gonna get t squared equals 4. So t is gonna be equal to root 4, which is 2. Okay? I think the other answer is 2 point. كيف how 2.1? Yeah, 2. The horizontal distance from the bottom of the tower to the place where the ball lands. Okay, x is equal to v node cosine theta t. Always. This is how you do it. Okay. V node cosine theta. طيب, v node is 21 meters per second. Cosine 0 is 1, by the way. Uh, huh. Yeah. 21 cosine 0, and then times the time, which is 2. And you get, on the calculator, you get 42. Because I thought that I was reading the part B by accident. The speed with which the ball hits the ground. Always the speed with which the ball hits the ground. If it was a projectile like this, it would be equal to the initial speed. But here, it's thrown horizontally. So it won't be like that. The question here, we said it was thrown upward. So it's going to go up, come back down. That's for free fall. Okay? But for horizontal, that ain't the case. Okay? That is not the case. So always for projectile, when you say speed, remember it's the magnitude of velocities. In projectile, you have Vx and you have Vy. You should know that Vx remains constant throughout the whole projectile. Always. We told you this many times. Vx is always equal to V node cosine theta. And V node is 21. Theta is 0, so 21 cosine 0, so it's 21. Vx is 21. I'm missing this Vy. Vy has its equation minus gt plus V node sine theta. Let's see. V node sine theta is obviously 0 because sine 0 is 0. And Vy is going to be equal to minus gt. So minus g, which is 10, time is 2. So Vy is equal to minus 20. نحن we want the speed, so it's the magnitude. So radical 21 squared plus 20 squared. We should get 29. Root 21 squared plus 20 squared. 29. Oh, exact answer. Question 21. Okay. Let V node be the magnitude of initial velocity of a projectile. Theta, the angle it makes with the horizontal, and g, the acceleration of free fall, and t, the time it is airborne. Which of the following are the correct expressions for different properties? The instantaneous horizontal component, yani V node x, is equal to what? V node cosine theta, we know this. The maximum elevation, yani the maximum height, is it V node squared sine theta over g? No, it should be V node squared sine squared theta over 2g. Not, this is wrong. The instantaneous vertical component of the object's velocity. The instantaneous vertical component, so V node y, is it V node sine theta plus gt? No, we said the V node y is V node sine theta. The range is V node squared sine theta cosine theta over g. Here, many people will not pick this. The range we know is V node squared sine 2 theta over g. Now, look, sine 2 theta is equal to sine theta cosine theta. If you ever see this, they're equal to each other, okay? Sine theta cosine theta, it's a trig identity that you're going to take in trigonometry and math later. But it's basically the same thing as sine 2 theta, okay? So if you ever see this, know that it's sine 2 theta, okay? So if you replace it with sine 2 theta, V node squared sine 2 theta over g, that is the rule we know for range. The instantaneous vertical component of the displacement, so y, is equal to V node t sine theta, V node sine theta t, minus half gt squared. Yes, now we know that it's y equals minus half gt squared plus V node sine theta t. They just rewrote it in a different way. They put this first, but they put t before sine theta, which I don't really see why. You can do that, I guess. No worry, يعني عادي. بس أنا I prefer writing it like they just rewrote it in a different way. They put it at the start and they put minus half gt squared second. Makes complete sense. Displacement, by the way, can either be x or y, but they said vertical. That's why they said y, and that's why we're using this rule. Okay, just know what you're looking for. Question 22. I think this was the canon question. Okay. A projectile is launched at 50 meters per second at an angle of 37 degrees within the horizontal. So v node theta g type. Projectile will remain airborne. Time total is equal, guys, so easy, to v node sine theta over g. Let's do this. It's gonna be 2 times 50 sine 37 على 10 6. Okay. For now, projectile motion ما بيجي أصعب من هيك except for one question that came in the CA that I'm gonna pull up now. Okay. Okay, so it was this question. I opened my video from last time, but basically it came in the CA and it didn't come like this. They just said, yeah, they just said find the vertical component and of the speed and the horizontal component. So let's ignore these, and I'm gonna show you basically what to do. Okay, according to what came. Please, they gave you the same thing, and they asked you find the vertical, find the horizontal. أول شيء you're gonna do is you're gonna find theta. How do you find theta? You take any point, and you're gonna do, you know, tan of the angle is equal to y over x, right? So we can just find theta by doing shift tan. You know, I should have used theta here instead of alpha. Okay, theta is equal to shift tan y over x. Let's see. Y is 20 in this case. X is, this is 1 because 0 0.5, 1, 1.5, 2. So here's 0 0.5. So 20 over 0 0.5. And let me get my calculator. Shift tan 40 because 20 over 0 0.5 is 40. You get 88.6. So listen, honestly, in the exam, the squares were tiny. I couldn't see shit, but like you could do it. Really, it's very possible. Okay, get an approximation because when you round your answer, it will be very close. So you're gonna get that theta is equal to 88.6. Now, this is your steps of solving. How would you find your angle? This is because in the exam they asked part A, find Vy, the vertical component, find Vx, V initial vertical. It was like this. You need theta for both of these. Okay? طيب. After this, you can now find the initial speed. Yeah. So to find the initial speed, you look at your graph and they gave you that the range is equal to 8 meters. And we know that the range is equal to v naught squared sine squared as they sine 2 theta over g. So just substitute. We're looking for v naught. The range 8 is equal to v naught squared sine 2 theta, 2 of whatever you got. Let's say 2 times 88.6 over g over 10 or 9.8, whatever. You solve this equation. Let me pull up my calculator. V naught squared sine 2 theta. So v naught squared sine. So I want you to multiply 9.8 by 8, right? We'll multiply on the other side. So 9.8 times 8. And we're going to divide by sine 2 times 88.6. So answer divided by sine 2 times 88.6. And then obviously it's v naught squared. So square root of this, you get 40. So now that you know your v node, you can find the initial, you can find v node y. You can go back to the question and you can find v node y, v node x. So you're going to do v node y is equal to v node sine theta. So it's going to be 40 v node times sine of the theta that we found, 88.6. And then the one here is going to be v node x is going to be equal to v node cosine theta, which is 40 cosine 88.6. So why did we go through all this steps? Because to find v node y, you need v node and you need theta. The first step I did, I found theta. The second step I found v node. To find v node, you need to do theta first. This is how you would have solved that one question that came in the CA. The answers to it were, I think, 3 and 4 or 4 and 3. I don't remember the order, but it was one of them. One of the order. Okay. That's it for this chapter. Thank you so much for watching.